Hello and welcome to Mechanical Y. Here I have a pint of water. In the United States, a pint is equal to 16 fluid ounces, or about 473 milliliters. There's ongoing controversy about using metric in place of US customary units when measuring liquid volume. In particular, metric has a distinct advantage of counting in a base 10 system, making decimal conversions easy for the average person. Ounces, cups, pints, and gallons seem much more cumbersome in this respect. But let's take a new perspective on the US customary system. It may not count in a convenient base 10 system, but it does count in a base 2 system, also known as binary. How is that? Let's start with the fundamental unit, the fluid ounce. And let's express this in terms of a binary system counting using ones and zeros. Defining 1 ounce is easy in binary. Then accordingly, we can represent 2 ounces. Nothing special so far, but let's look at 4 ounces, officially known as a gill. When we represent a gill in binary, we see a pattern begin to emerge. We can continue up in this fashion, constantly doubling to get the following relationships. 2 gills make 1 cup, 2 cups make 1 pint, 2 pints make a quart, and 2 quarts make a half gallon, which does not have a distinct name of its own, but is a common fluid measure used in the United States nonetheless. And finally, 2 half gallons will obviously make 1 gallon. In other words, the US customary system of measurements for fluids makes as much sense in a binary system as a metric system, like the International System of Units, does in a decimal system. And yes, we can represent decimals as well. Half an ounce is equal to 1 tablespoon. And though they are not used anymore, smaller measures were commonly used in the past, such as a half tablespoon being represented by a dessert spoon, and a half of a dessert spoon was defined by a now obsolete definition of the teaspoon. Furthermore, a careful observer will note that the full range of 1 ounce to 1 gallon can be expressed exactly in an 8-bit binary system, the same type of 8-bit binary system of counting used in modern computing. Okay, but I'm not programmed like a modern computer. I count in a base 10 system, and the metric system makes more sense to me, right? Well, yes and no. I do understand decimals very well, and metric does make precise conversions very easy for me. The standardization of prefixes in many metric systems make communicating quantities very clear. But there is an intuitive nature about a binary system. For instance, if I were to take a random liquid volume that I may or may not have precisely defined, mentally I can visualize what is double that volume. Likewise, I can visualize what is half that volume. Thinking of quantities in terms of doubles and halves can be quick and convenient, regardless of what actually defines that quantity. So am I saying that the US customary system of units is better than the metric system? No, not at all. Right now I'm not saying that one system is better or worse than the other. What I am saying is that the US customary system of fluid measures does make sense and does have a useful logic behind it. Well, thank you for watching. I hope you found this interesting. If you did, please like and share this video, and please subscribe to stay up to date on new content. Also, please visit us at our website at www.mechanical-y.com.